This project is an initiative to protect the peatlands around the world. Save the peatlands, save our planet. My name is Mitun Das. I am an IoT enthusiast and I care for our planet. Peatlands are a type of wetlands which are among the most valuable ecosystems on Earth, covering only 3% of total land surface but holds 30% of all carbon on land. They are critical for preserving global biodiversity, provide safe drinking water, minimize flood risk and help address climate change. Making sure the carbon in peatlands go undisturbed is the key to regulating climate, as damaged peatlands can cause a massive release of carbon into the air. Peatlands absorb pollutants from the atmosphere, including nitrogen, sulfur dioxide, heavy metals and carbon. As a result, water that flows out of peatlands into the ground, or rivers come out clean, like a natural filtration system. While some peatlands are draining naturally, many others are draining for us. In Southeast Asia, peatlands have been drained for conversion to plantations, for palm oil and paper pulp. In Europe and North America, lowland peatlands have been drained for vegetables, cereals and livestock pastures. Agriculture, forestry and mining have so far impacted about 25% of the peatlands on Earth. When peatlands are drained, they become highly vulnerable to peat fire. A simple discarded cigarette can cause huge devastation, degradation of the resource base, accelerated carbon emission and health issues for local communities. Dry peat can burn for days or weeks, even smoldering underground and re-emerging away from the initial source. Early detection of drying peatland and sign of fire is very important to protect them. The 1997 Indonesia fire, which was a result of drying peatland, lasted for months. Burning 11.7 million hectare land, destroying 4.5 to 6 million hectare of species-rich Dipterocarp forest. Estimated carbon emissions from these fires on peatlands were 0.81 to 2.57 gigatons, equivalent to 13 to 40% of annual global fossil fuel emissions. Introducing Peatguard, a low-cost and low-power smart device which provides real-time sensor data monitor and alerts. The device is powered by solar energy, reducing fossil fuel use and greenhouse gas emission. It uses LoRa protocol to transmit data to cloud, eliminating the cost of cellular connection and perfect fit for low-power applications. Device runs on Heltec wireless light microcontroller. Soil moisture sensor, CO2 gas sensor and temperature sensor are connected to the MC. GPS module is connected as well for accurate device location. A LiPo battery powers the MC, which is charged by solar energy via solar charging module. The device sends data every 5 minutes to Helium network. Adopted open fleet concept, sharing the responsibility to every conservationist. Any small or big, even individual can join the network and share sensor data to everyone. This gives complete data transparency. There is no single point of failure as responsibility is shared. Device automatically gets the GPS location, so no manual location insertion needed. Anyone can view the data on website and anyone can subscribe to receive email alerts. After a lot of research and testing, I realized a generic ML model is not a good fit as every peatland is different in terms of weather and nature. So I decided to use configuration which can be applied to each device independently. Most of the IoT prototype fail in production because of scalability. I have built my solution on complete serverless architecture deployed on AWS Cloud. Infrastructure is auto-scalable and ready for production use. Used App Sync for real-time data update on the dashboard. Progressive web app design provides native look. Let's build this together and fight the climate change. Inviting everyone to take charge and take this initiative forward to make real impact. Here is a quick demo. Due to shortage of time, I am showing some key features. Under the cover hardwares in the dashboard. I am moving soil moisture sensor from a wet muddy soil to very dry soil to represent what happens when peatlands are drying. I also put a fire to show how device can detect the change and send emails. I shared a link of the full demo video which explains how the device works in details. The back-end infrastructure is production-ready which can be used for similar use cases such as wildfire detection, smart city solutions or wildlife conservation projects where we need to stream data from edge devices to cloud, send alerts based on some conditions and display data on dashboard. Thanks for watching. I would be happy to answer any question you might have.
Created using Powtoon.